Thank you everyone for joining. My name is Dmitry Vinnik, and as you can tell, hopefully we are going to talk about modern web testing. So, first and foremost, I always like to establish the goals for the presentation, so you can still make a conscious choice whether this session worth your time or maybe the one upstairs is more up to what you're looking for. And with the goals overall, first thing I'd like to discuss the test context, and so you can actually choose the test context that fit your individual use case. Next, we will dive into figuring out the right level of testing, so you don't just end up doing end-to-end testing alone and with the so-called reverse pyramid or an ice cone test pattern, as most of the enterprise companies today are facing. And the last but not least, I hope to make it somewhat practical, so you'll figure out maybe individual tool or an approach that you might want to bring back to your workplace the next time you go to work. We're not going to go into details or instructions step by step for individual tool. It's more of a conceptual and abstract approach. While I still will highlight a couple of tools, I highly encourage you, if anything interests you, to look into the more deep dive into the approaches and tools I'll bring up. The slides I'll also share, they will have all the information available for you. So, but first, I really want to go into details around testing. When it comes to testing, the good question to ask is, how do we even test in the first place? And hopefully you've all seen the test pyramid in the past, where this is an ideal version, of course, that we are supposed to have the highest number of unit tests. That's why it's on the bottom layer, meaning that it's the widest layer. Trying to highlight that you're supposed to start with the unit tests and have as many of them as you can. And the reason why you're trying to have as many of those tests as possible is because they are the lowest cost in terms of maintenance and creating those tests. Also, they're the fastest ones running. Hopefully, there will be the test that can give you quick feedback when you're developing a new feature or fixing a bug of some sort. And the last main point is that we have to acknowledge that as good of a unit test might be in terms of the cost, benefit, and being the fastest ones, they don't give you the highest level of fidelity. Or in other words, you're not confident enough in the overall quality of your system just by running the unit tests. That's why we go up a bit and discuss the integration tests, which might involve multiple units of work interacting with one another, and that's where the testing will reside on this level. And the end-to-end test is where we will focus the most for the entirety of today's presentation. Is slightly different from the previous levels, mostly because it's the costliest to maintain and to write. I'm sure you've all encountered end-to-end tests, and that's why you are here in the first place. Because one of the main issues is they are the slowest to run and to actually execute. That's why they often end up being just a regression suite at most organizations that run them. But the good thing is that it actually gives you the highest representation of what your user interacts with on a production case. Or in other words, it gives you the highest confidence level in your overall software. That's why you have to have the least number of these tests, because there are only very few basic use cases that your customer is going to interact with on a daily basis. That's why you have end-to-end tests on the top of your pyramid. So that was ideal test pyramid. Unfortunately, when it comes to testing web, it's slightly different. And for the most part, you have something called an ice cone pattern, or it looks quite decent. That being said, it's a very unfortunate pattern that most of us encounter, and most of the companies I've interacted with, at least at this point, are encountering this issue, where you have the fewest number of unit tests in place. A service test, the same thing as integration tests, whatever name you want to use. But the main issue is that they have the largest number of end-to-end tests. The main issue here is we often undervalue the importance of knowing when to write tests. We all can write tests to some extent, because they all follow the same simple principle of arranging the test data, acting on the data, and asserting the data. It's a very simple three principles. So it's simple enough to write the test, but to figure out when to write it and what use cases to write it for, it's something you have to learn and improve, and it comes with the experience more often than not. That's why when you just throw the engineers on a problem or on a bug, you end up with so many end-to-end tests that you can't basically bear it, and you're going to call and blame every single test tool out there in the market, or keep saying that Selenium is slow or Selenium is bad, because you've actually written way too many for unnecessary use cases. And of course, the manual testing, whether you have it or not, it's not the point of today's talk. That being said, some of the points I'll make at the end will hopefully assist you with transitioning away from manual testing as well. Of course, we can't just stay on this reverse pyramid or ice cone test pyramid scenario. We want to change that. And that's what we'll try to do today. And for the sake of time, and just to set the context, I have to make sure that we're all on the same page what kind of application we will assume to be testing throughout today's presentation. And in terms of this something that we'll be trying to test today, it will be this common thing that everyone uses for any sort of demonstration is this todomvc.com application. What I don't like about this demo app that everyone uses is the lack of contrast. That being said, it's the simple functionality where you can create to-do items, you can change their state, you can complete them, you can close them, delete them, simple CRUD operations. But again, it's not as important what kind of app we have. It's more of a setting up the context, making sure I don't just talk out of nowhere. So with this kind of context being set, let's go back to testing a bit. So, as any consultant out there will tell you, it depends. So when it comes to testing, I really want to establish the very first case we'll be looking at and the very first argument and point I'll be making today. So imagine you have the application where the backend is written in Java, and very often what the teams end up doing is writing tests in Java, whether it's end-to-end tests or unit tests, or again, for the case of end-to-end, it will be Selenium WebDriver using Java bindings. So that's the very first case we'll consider today. And the very first point I want to make here is that there is a major problem with this approach of writing a backend code in Java and also writing the end-to-end tests in Java as well. And the reason why I'm saying that is when it comes to web testing, I really encourage people to move away from backend testing. Because the customer, unless you're API first and only company, the customer, the end user, will be only working and interacting with your user interface. And that's why I always encourage people to focus their testing effort. And so the reason why I'm saying that in the first place is that one of the things I'll be making a point of is the idea of hybrid model. When it comes to the hybrid model, it's a very popular notion these days, especially in America, where they're trying to transition engineers and testers to be a single role, where everyone has a single title, software engineer, where you're supposed to have, you're supposed to keep in mind the regular software principle, like, you know, have a dry design, you keep it simple, you have to write code as concise as possible. So those regular simple software principles that you have to keep in mind, but also you're supposed to represent a testing expertise that hopefully the quality engineers are, you know, known for. And basic combination of the two is that perfect balance the company is trying to achieve. That's why they come up with this hybrid model. But honestly, it's been an issue, again, in the companies that are trying to implement this, because the same problem, people undervalue the importance of testing. While they focus on making sure that those testers who go through the transition learn about software principles, they disregard often teaching engineers how to write tests and when to write tests. So regardless of whether you're going for the hybrid model or not, in terms of the official transition, the importance of highlighting the notion of testing expertise and the software development practices is important for anyone. Domain-driven design is one of the other concepts that really encourages developers and testers transition to testing UI in the UI. Because when it comes to domain-driven design, which has been more popular in the recent years, I would say, the idea behind it is fairly simple, is that you're trying to learn about the domain you're in, or in other words, you're trying to learn what kind of problem you're solving. For example, I currently work in a company, Salesforce, where the product I'm working with is the website building tool based on Salesforce data. Working on this domain of website building tools would encourage me to explore Wix, Squarespace, WordPress. This is what I mean by knowing your domain. And the most important thing about domain-driven design is the idea of ubiquitous language. If you're a tester and you write your test code in the backend, while your production engineers who write the UI for the end user, they only write the code in JavaScript for the front end, there is this disconnect which you want to avoid. You want to write your test the same language, the client-side, the front-end language, as your production engineers will be writing it for the customer. So that's why we're trying to transition away from back-end towards the front-end. And again, it's the same idea. If you want to keep it user-centric, if you want to keep your tests for web user-centric, you need to exist on a domain or a context of your user, and it would be the front end. So, if you're still not convinced, and that's totally fine, it took me actually a while to even think about it in these terms that it's important to go to the front end. I'm trying to just highlight just from the title itself that I've called it modern web testing. When it comes to web, it's important to acknowledge the power of JavaScript. The fact that we have so many assertion libraries, if your test engineers today haven't mostly writing the test on the back end, JavaScript makes it easy to go through the transition because the flow is the same. It's the arranging of the data, acting on it, and asserting that data. So it's simple enough, and the learning curve would not be steep. The process libraries, or in other words, methodology libraries that JavaScript helps you with, is also there. And more importantly is the fact that enterprise obviously acknowledges the JavaScript in addition to the open source, or the fact that companies come up with their own tools and solutions that help you with testing in the JavaScript. Give you an example of assertion libraries. There are so many of them, but one of the most common ones is Chai and Jasmine. I always like those names. They really remind me about drinking a lot. Process libraries. If you go for the behavioral-driven development, and that's something you're trying to implement to your backend using something like Cucumber, you have the same library for the JavaScript. And when it comes to enterprise, let's say there is a visual testing you're trying to do. Apply Tools is a great solution to implement it in your production use case and have the quality testing for that as well. But once again, when it comes to speaking language of the web, it's not just generic JavaScript as a whole. In terms of testing, Node.js plays a major role for that. And that's why I hope it's a front-end conference so people have encountered the Node.js in the past. But ultimately, the main point is that you can write it for the server side and the client side. So it's isomorphic. It's very flexible. It's customizable. And thanks, we have package managers. Before it was just NPM. Now it's even more than that. So Node.js is extremely powerful. That's why it's a major tool for testing when it comes to testing for the client side, which I'll be bringing up in a second as a couple of examples. So if I were to look back at the test pyramid that we've looked at the very first couple slides, the important thing here is that we will be looking at the web test pyramid, not just the end-to-end testing on the top, but how do you go again back to this idea of having as many unit tests as possible, then having a certain, a little bit fewer integration tests and even fewer end-to-end tests, while still focusing on the web. So acknowledging the testing of the web and keeping it user-centric, but don't just try it simply end-to-end regression suites. And that's what we will start by highlighting unit testing, particularly in the web context. So when it comes to the unit testing, as I've said before, there are lots of libraries for that. One of the examples I just want to give it for the sake of the illustration is Jasmine. So imagine I have a function, a simple production function in my create to-do application. And in that function, it does basically nothing. It just takes an input, converts it in a certain JSON format, and returns it for the consumption. It's a simple unit of work, simple function. Doesn't really matter what it really does. What's important is when it comes to writing a test, and again, if you're written only backend tests outside of the client side, outside of the JavaScript, you just have to acknowledge the fact that the learning curve is not steep, because it's again the same thing. You name your test suite, you name your test, then you initialize, you arrange the data, you act on the data. You basically stop some test data to invoke the operation. And then you do the assertion. So the same principle of arrange, act, and assert is still in place. So there is not much to learn. The curve, again, is not steep. And that's, again, the main point I'll be making throughout today. And you're still focusing more on the UI, on the front end, while not writing as many end-to-end tests. If we go up the pyramid to the integration test, you have to bring up something amazing that's been talked about a lot. Jest is just awesome. And I'm sure you've all, at least, or a couple of you have tried it in the past, one way or another. One of the things I'll bring up today would be snapshot testing, because it really helps you to exercise the UI while not actually loading the front end as much. Basically, if you say we have a React component, in our case, it's a create to do component, which ultimately renders a button of some sort. It doesn't really matter what it does again, but the fact is we end up with a DOM after it gets rendered. And to exercise and make sure that rendered content, the rendered DOM, is the DOM we expect it to be, just helps us to basically write a simple test. It's not as verbose as the Jasmine might be or other languages or frameworks might have. It's the same couple lines of code. Of course, you have to first initialize your test suite and name it a certain way. But after you do that, you just initialize the component that you want to exercise and test. You convert it to JSON and you make sure the snapshots match. Snapshots is basically what happens here. It renders the button or button that gets generated along with the style, because the button for the to-do had a style behind it, and it generates that, saves it as a snapshot, and just runs with it. I would say when it comes to just snapshot testing, I've seen it the most successful being in the legacy systems, because sometimes developers have a hard time updating snapshot every time they make a major change to the application. But as long as you keep it to the component level, not the entire application snapshot, but the individual components, you will be in a good place. While still, the jest follows the principle of being fairly fast, comparing again to the end-to-end or the Selenium or whatever you run, being more involving than just unit tests, but still you get to test front-end more excessively. So, if I were to just reflect on these first two levels of the unit tests and the integration test, they all had one single focus. And the main focus of those two levels were developers. In other words, when it comes to those two tests, you are writing them in order to give a feedback to the developers. And the only way developers will ever run anything, in this case, integration or unit test, is for you to make them easy to write them, easy to execute them, and actually get them the results fast. Because it's all about that feedback loop, the whole agile approach that we want to get it quick, want to iterate. And the only thing developers will ever do is something that runs quicker than the end-to-end. So, and basically the main point behind it. It's good for those two levels, but it's not good enough for end-to-end, unfortunately. The focus for the end-to-end is different. When it comes to end-to-end tests, which again, the costliest, the slowest, but the highest confidence level that's given to you as a result of those, they force you to shift the focus from developers towards users or customers. You can also call it user-centric testing. But that's easier said than done. It's fairly complex to do, right? To just transition and write your test if it was a user-centric. And in terms of writing the end-to-end test, it's all about figuring out what use cases your customer really go through on a daily basis. Do not write tests, end-to-end tests for every single edge case that you encounter, every single bug that you fix. Try to stay low on the test pyramid, because otherwise they will never be run by a person, they'll only be run by continuous integration. And you don't want that. You already have enough tests. So, if I were to ask you what the common way to perform end-to-end testing, obviously Selenium WebDriver comes up fairly quickly. When it comes to Selenium WebDriver, we have to acknowledge as a de facto end-to-end tool, and it's a great tool. It will establish the testing standards. Today, most job description for testers will contain a knowledge of the Selenium WebDriver, and it's important. It's fairly generic, or in other words, it covers all sorts of UI frameworks. It's not UI framework specific, and it has lots of integrations out there built by the open source or the enterprise. So it's a very successful tool. In terms of the architecture is fairly simple. You don't have to try to look closer, but the main point is that you have individual browser bindings, you have the generic Selenium remote server, and the language bindings. And that's one of the biggest successes of Selenium, is that the community is so large that almost every single programming language out there has a binding to Selenium, so you can write it in the language of your choice, which is great. But that's why, if I will still keep in mind that I'm encouraging people to move towards the client-side testing for the front end and for the customer, this is where WebDriver.js comes up. Or in other words, Selenium WebDriver.js. By the way, it's important, the capitalization, because WebDriver.js, both G and S capital, it's a different framework altogether. Don't get confused. Naming things is hard. So, Selenium WebDriver.js is again the same principles. It's still de facto end-to-end tool because it's Selenium. It's testing standards it brings up with you. It's generic and it has lots of integrations. In terms of the architecture, again, it's still Selenium. The only difference is that the bindings, you only have a Node.js. So basically, you write it in JavaScript. That's the only difference. So if you're just trying to transition to the front end, writing your end-to-end tests, that might be the good solution if you already have Selenium WebDriver in place that's been written in C#, Java, whatever, on the backend, on the server side you might have already done. Give you an example how the test looks like. Nothing special again. Fairly simplistic. In other words, what we have here is the test that we name a certain way. Then we establish the driver the same way you would do it in Java, as an example. You establish a driver, you have to close it afterwards if it was initialized. Then you create a test. In our case, we want to make sure we can create a to-do element with the valid data. So what we do, the same exact principle of I'm going to the URL of my choice. I'm trying to find the element, in this case, basically the to-do name that I will fill out with a new name for the to-do element. And then I make sure the element shows up, or basically you wait for the element. Exactly the same principle, arranging, acting, and asserting. Doesn't matter how it's actually written. What I'm trying to highlight here is that it's exactly the same pattern as you probably encountered in the past, while still written in JavaScript. Unfortunately, we don't just have a good part, otherwise this talk would be kind of a non-existent. So that's why when it comes to end-to-end tests, they have major complexities behind them. And just the four to mention, it's how do you find elements, especially one of the major issues is the flackiness of tests. Or in other words, when you fail to find an element because it hasn't been rendered yet, you can't really wait for the element forever. So that's one of the major issues that end-to-end tests and test frameworks encounter on a daily basis. How do you locate those elements is also important. What's the strategy that you follow? How do you write the test? What is the test flow? Is it asynchronous, synchronous? Do we have to go through callback hell? Do we have that in test infrastructure? You probably don't want to, but unfortunately, some people had to go through that. And the last part is that, is it specific to any individual single-page frameworks, like UI frameworks? If it's specific for Angular, specific for React, Vue, and so on and so forth. I would probably spend an hour just iterating through maybe half of the UI frameworks out there. But when it comes to WebDriver.js, if I were to look at it from the perspective of these four complexities, when it comes to selectors and how we do selectors in WebDriver.js, exactly the same way as you do it in Selenium WebDriver. Basically ID, CSS name, class name, XPath, whatever you desire. Locate the strategy, the same as a WebDriver. You do the bilocators, nothing special here. Test flows, they used to have something called a promise manager to help you with writing code, test code, top to bottom. So test engineers didn't have to go through the somewhat complicated asynchronous flows that you might have had to go through before. Currently, fortunately, promise manager was deprecated. They have other ways to make it synchronous, but at least in terms of writing the code, it's still top to bottom. So it simplifies and makes it easier, bar for entry for test engineers if they haven't done it in the past, haven't done JavaScript in the past. In terms of what kind of frameworks it focuses on, I said before, it's very generic. You can run it for any sort of frameworks. As good as this tool is, it's somewhat limited, maybe because it's generic. If you're thinking of something better, especially better for your individual case, because your use case matters, I want to bring up another case, special case. Let's say we use Angular in our scenario. And when it comes to Angular, if you obviously it's a front-end conference, so people know how Angular would look like. But when it comes to the application that we test, the to-do MVC, it has a bunch of models, iterators, repeaters, and so on and so forth. But you can notice that it has, if you've never done Angular, it has this special kind of tags like ng class, ng repeat, and so on and so forth, which you don't generally have in the static websites, as an example. So to basically target these elements, there might be a better way to test it. And of course, you will still test it with the unit tests, with the integration tests. But when it comes to end-to-end tests, you have a better solution. And that's why we don't have to use WebDriver.js. We can use Protractor. Fortunately enough, the Angular team and that's an exciting part, it's the same team behind the production Angular code. There's also a team that does Protractor, or basically the end-to-end testing tool for the Angular apps. And the coolest thing about Protractor is that first, it's based on WebDriver, so it has everything WebDriver has and then some. It still uses the generic server, but more importantly, it interacts with the Angular app. It bypasses this issue of waiting for the element because it knows exactly when Angular app finishes loading. That's again, the major issue with end-to-end test, it's flackiness. It's not knowing when it's ready to be tested. And that's what bypassed by this flow. When it comes to the Protractor, it focuses on elements bindings. Locator strategy is similar to the previous, to the WebDriver.js, but here you can really focus on models, iterators, controllers, so whatever Angular-specific elements might be. Test flow-wise, it really waits for the application to load. It's a power of the fact that it's built by the same team as a production team. And it's very Angular-specific. If I were to give you an example, the same exact flow, I create a test suite. I initialize my test. I have a browser element, I load the URL. You can see what's important here to acknowledge is this by model element. I can target those ng models, that Angular-specific targets. And the same thing, I do the assertion, I wait for the element. But in this case, you don't have to go through the complexities of making sure the application is loaded. The Protractor will make sure for you, so you don't have to worry about that as much. So Angular is great and all, but we have, for better or for worse, we have so many more UI frameworks out there. Obviously, it's React, Vue, Ember, Backbone, and so on and so forth. And if you were asking, can you use Protractor with React, for example? You can. You can. You just have to turn off the synchronization, because the thing with Protractor, it's really waiting for the app to be loaded. If it's a React app, it will never finish loading the Angular. So you can turn it off, and you can keep running your tests. The problem, though, it's not the best approach. The selectors are not the same. You're basically missing out on the those special selectors that Protractor gives you. It doesn't really worth the effort of writing Protractor tests for the React. The only case I can consider myself, why you would even consider this scenario, is if you've built a lot of Protractor tests for your Angular app, now you decide to switch to React, while the same functionality remain. You might have to switch over while still existing on Protractor. That's an important point, which I'll bring up in a couple slides. But when it comes to considering something else outside of Selenium, because so far I've talked about Selenium quite a bit, non-Selenium UI test frameworks have been quite popular in the past. And the two things I've mentioned today, it will be TestCafe and the Cypress.io. Two main kind of solutions out there that I've seen in the past. So, if we've learned anything so far, is the fact that there are common patterns. There are patterns everywhere. And when it comes to patterns for these non-Selenium UI test frameworks, first of all, it's important to figure out how they handle waits. Because as I've said, the major issue with end-to-end frameworks is the flackiness of tests. Then we need to know whether they can properly run parallel execution of tests or for different browsers. It's an important point to make when it comes to choosing a solution for your team. The rapid test development has been, again, the major point of contention for developers and testers, or in other words, how fast can I run the test, or how fast the changes to my tests will be represented in the app I'm running my test automation against. So that's an important point that these solutions really focus on. And as you remember that ice cone, on the top we had the manual testing. How do we transition manual testers towards writing more automation? A first and a great step would be recording the operations manually, basically, clicking the application around, recording that, converting it to script, and running it automatically. This functionality of record and play, and both of the solutions I will highlight today, the TestCafe and the Cypress.io, has been a major focus as well. So if you look at the TestCafe, just as an overview in terms of those patterns, it handles waits perfectly. I mean, it's perfect to some extent in the sense that it's really waiting for the requests to complete, or like XHR requests, before it loads and executes the element, starts asserting on the elements. An important part that it doesn't just execute tests in parallel if you want to. And it also can be run for different browsers, which unfortunately you cannot do for Cypress.io. So you can run it for Firefox here as well, or Safari, whatever you want, not just Chrome-based browsers. It has a great rapid test development integrations. They've made a major progress in the last year. The website improved greatly, tutorials have improved as well. And in terms of the recorders and IDE, if I were to give you an example of how you even write tests in the first place and how they handle waits for you and keep it synchronous in terms of writing the code, they really embrace this idea of stream API, or how you write the stream APIs. Or in other words, initialize your test, you're making sure the URL loads, then you create the test itself, and then it's similar if you write promises. It does not go to the next level of the test until the element gets loaded or until the request has been completed. So you basically, same way, you try to find an element, you write a certain value to it, and then you do the assertion. Again, it's not about how you write the test. It's that the points and the logic behind them is still the same, exactly the same as it is in the other test frameworks. And in terms of the recorders, they have a very decent automation behind, especially like click and play or drag and drop when it comes to test automations. As I've said before, they have a great website with awesome documentation. Not as good as Cypress.io yet, but they're making a major progress on top around it. So, when it comes to Cypress.io, if I were just to highlight this automation framework from the common patterns principle point of view, they handle waits decently as well, the similar way the request-wise as the TestCafe does. But the important thing I have to say is, when it comes to parallel execution, you can run tests in parallel, sure, but unfortunately you can only run these tests for Chromium-based browsers, which is not a big deal for maybe small startups or medium-sized companies. When it comes to the enterprise, very frequently I see the important need for them to be able to maintain and support other browsers, whether it's Firefox, older Internet Explorers, and things like that. Especially if you're working like with the customers, let's say, in a part of Asia, which still might be using IE 9. I say it from the experience, it's always a nightmare. But it's a reality for many enterprise companies. Rapid test development is a major selling point for Cypress.io. They have a great integration with the browser, or as they say, we run your tests and you write them in the browser. So try to make it easier for you for sure. And the recorder that they have is also great. If I were to give you an example how you write those tests, again, you can notice that they all look almost exactly the same. You name your test, you name your test suite, you go to the website, you find an element, you can send the password, the username, whatever you want. An important thing to highlight, it's very extent, like the API and the work they put into making it developer friendly is enormous. You can see how easy it is to even guess what this API does just from reading the method. You don't have to go to the documentation. You can also see that it can interact with the cookies, which has been a major point of contention for many end-to-end frameworks, and it's been very verbose in some of the automation UI frameworks out there. So Cypress.io does a great job, and if you don't really mind the fact that it's focused on the Chromium-based browsers, I would highly recommend trying out Cypress.io. In terms of the IDEs that they have and how easy it is to make writing your test code and executing it easier, you can basically do it very simple. The same way you would put a debug point if you're using in your Eclipse or IntelliJ IDE, you can also put a breakpoint using the code. The same way in JavaScript, you would just put a debugger point, you can put a pause in the Cypress. I'm not going to go through code here again, but as I've said, probably Cypress.io has been my favorite in terms of documentation in any product I've seen out there in the wild. So I highly encourage you to try it out and see what they have to offer. But what's important here is finding the right tool for the right problem or for the right team. And when it comes to that, there are so many test frameworks, and especially even though I've mentioned just very few, there are so many more. There's the WebDriver data, there's the WebDriver IO. There is Nightwatch.js, which is an older framework, not even maintained, I believe, anymore. There is a WD, there is a Nemo, and a lot more frameworks. What's important is to avoid the tool mix-up. And what I'm saying here is try to have the unified direction in your test team. If your testing is complex, to test complex systems, you're basically doing the double the work and no real benefit. If it's hard to exercise or run your tests, you're not making it easier for anyone. I've encountered in the past many times where I would spend more time fixing tests and actually getting the value out of them to fix my real features, the real bugs that were hopefully uncovered by the tests. You don't want to spend your effort in that area. And the reason why I've always encouraged to avoid the mix-up is because it increases this complexity. Basically, the whole point I've highlighted with domain-driven design is just non-existent. You don't speak the same language anymore. Because even within the same testing team, one team writes Cypress and one team writes like Protractor. You want to avoid that. Because again, you have to like, oh, this is how you write API, or this is how you write the assertions. Just think of from the perspective of a new hire and how easy it is to get them up and running, or how complex it is, and you'll get your answer. How do you choose? That's an important question to ask. How do you choose what framework to use? Look at the open source project or the GitHub stars. It's probably a good place to start. More important, I would say, look at the NPM downloads. It might be better metrics to use when it comes to figuring out the popularity of the tool. Figure out if there are external integrations or some enterprise support for the solution. And really do the proof of concept before jumping ships and just doing the testing in the tool of your choice. Try to write a couple tests in Cypress.io, and TestCafe, Protractor, and see what works for you. But more importantly, find how flexible the solution is. Or in other words, find something that works and easily can be customized. If you're going for Protractor, it means you're committing to Angular. But if you're going for WebDriver JS, it's very generic. You can go to any solution. Cypress.io, also fairly generic. So keep that in mind. Keep it flexible. When it comes to the use case, it's important what your team is doing, what your team expertise is in. So flexibility-wise, as I said before, you have to keep in mind how complex and costly it will be to transition from one tool to another. What's the return of investment to even do that transition? Maybe you're fine with WebDriver. There is no even point to worry about that. Can you change it? And more importantly, replace it. You don't want to be, at mercy of the individual open source community out there. And the use case-wise, what's important is, as I've said before, your team expertise, what the framework you use, or maybe you're changing the framework. The fact that you're about to change is important to acknowledge. And can your test infrastructure even handle that in the first place? So with that, let me end it by giving a call for action. Evaluate your test architecture. See what can be changed or improved before just switching to the framework. Maybe switching is not the right choice. Have domain boundaries. Figure out what domain you're working in, what framework you might be working with, or what change you might be doing in your team in the upcoming future. Unify your strategy. Don't have the test and the tool mix up. And more importantly, experiment. Keep it interesting. And with that, I'd like to thank you and thank you for your time. Thank you so much.